Hey, 8th graders! Hopefully you are excited to do dilations. If not, let's get excited. I saw a lot of students who are struggling with dilations, and we definitely want to master this before going into high school. So today is a great opportunity to practice dilations, practice using scale factor to either enlarge or reduce a figure. Here we go. Let's take a look at this little triangle. Isn't it cute? Let's give it a little happy face. The triangle is happy to be there. We are going to be, let's see, well actually I gotta figure it out. Let's look at this. Oh, it's a rule. All right, what's this rule telling me to do? Well, it looks like 2 times x is right here and 2 times y is right there. Oh, the scale factor is 2 and I'm enlarging this thing by twice the size, right? So that means that it's going to get bigger. And I need to multiply the coordinates by 2. Well, what in the world do I do with coordinates? Let's look. What's a coordinate? Well, a coordinate is an ordered pair, right? X and Y is a coordinate, and it means it's a location on this coordinate plane, this graph. So let's look at all the vertices. Here's a vertex, and there's a vertex. Now he looks like he's on roller skates, or she, or whatever it is. Okay, so now I'm going to find the location, the X and Y coordinate for that particular vertex. So I'm going to name it. Let's name it. Let's just name it, I don't know, can, because you can do dilations. Okay, I'll stop. All right, where is C? We're going to do our pre-image, C-A-N. There we go. And where is C located? Well, if I go to the origin, to 0, and I go over 1, 2 on the X, and then up 1 on the Y-axis, then I find it. So it's going to be the coordinate 2, 1. And then where is A located? Well, A, back to the origin again, I go over 4 and up 1. So that's 4 and 1. And then I got to go back to the origin again and start from there. And then go over 1, 2 and up 1, 2, 3, 4, 5. So 2 and 5. Perfect. All right. Now that scale factor, all it's telling me to do is make sure to multiply everything by 2. Everything, right? So 2 times 2 is 4. That becomes 4. 1 times 2 is 2. So my new image, C prime, well, not really my new image, but my new vertex, C prime, is going to be located at 4 and 2. Where's A prime going to be located? Well, 4 times 2 is 8, all right, and 1 times 2 is 2. All right, that's good. And where's N prime? Let's see. 2 times 2 is 4. 5 times 2 is 10. Good. Now I know where my new vertices are, and I can go ahead and plot them on the coordinate plane. So let's go ahead and do that. I'll do it in red for fun. And let's see. I'm going to plot my new coordinates. Here they are. 4 and 2 is going to be located at 4 and 2. Here it is. Okay, so there's my C prime. And 8 and 2, I got to go over 8 on the X and up 2 on the Y. So there is my A prime. And then for N, I need to go over 4 on the X and 10 on the Y. So over 4 on the X-axis and then up 10 on the Y-axis. And there is my new N. Whoops, I can't. My face is in the way. All right, here we go. I'm going to draw as much as I can anyways. There he is. All right. Yay. Nice happy triangle. It's enlarged, and remember, everything is enlarged by the same scale factor. So if you look at corresponding side lengths, you'll notice that the corresponding side lengths are enlarged, have been dilated by the same amount. This was 4, and now it looks like it's 8, right? Because 4 times 2 is 8. The base was 2 here, and now it looks like it's 4, because 2 times 4 is, 2 times 2, is 4. Saying it all backwards. Anyways, that is how you complete a dilation. If you need to reference this video, go back to it. I want you to go to the next slide and practice it yourself. You can do it. See you later.